Hello and welcome to another Solana tutorial. You know, I always get excited when they add new instructions to the core programs. And they recently added a new instruction to the system program. So I need to have a look at that. It's for creating pre-funded accounts. And today we're gonna analyze why we need that, how we use it, and when you should be using it as well. So without further ado, let's step right in and look at the new system program instruction. This is so exciting for me. I don't know why I'm getting so excited about this, but I'm getting excited about this. So I came across this in Answer's blog about what's new in Agave 4.0, the validator client. And for me as a dev, next to all those things, the most interesting things are the feature gate activations, aka what changes on the network. And we already talked about P token, made separate videos on that. Stake V5 is getting active. Now we finally have that limit of the 1 sol in staking accounts. We've been talking about that for forever basically. But yeah, the thing I want to talk about today is this pre-funded account creation, the SIMD 312, which gives us a new system program instruction called createAccountAllowPrefund. And that's the thing we're gonna have a look at today. But first, maybe let's revisit the regular create account instruction from the system program just to get us up to speed and build the base understanding of why this is gonna be helpful. Let's break this down and make a point. Let's go. That's better. My hair is not so annoying here. Brr is what my shirt says. Brr. Oh, that tickles. It tickles. Stop it. Sorry, I'm a grown-up man. What am I doing? I do PNPM the Solana kit. Cause guys, I still prefer the Solana kit over the Web3 chairs, even in version 3. Just so used to it. Let's go. Let's do a kit script. We are going to devnet, create me a key, pre-DC. I'm having too much fun creating keys. Pre3, PESP. Oh, I like that. I like this key. I'm gonna take this one. And we're gonna go to devnet and gonna airdrop myself a sol. I still have some here. I'm just gonna do a manual airdrop here, have half a sol. There you go. Okay, good. Now, as for instructions, we're gonna do a system program instruction. So we will need Solana program system, and from here we can get a create account instruction. This is nothing new. This is how we always did it. We create a new account. The new account will be a new key pair. So we generate ourselves a key pair signer. This is the account that we want to create. The payer will be my payer. That's the guy paying for that, and then we will need to know rent, and I'll get that from the RPC get minimum balance for rent exemption. Let's create an account with 0 data lore, just the absolute bare minimum, and that's gonna be my Lamperts. Oh, I forgot to await this. Space I said is 0. I should also maybe, you know what, let's do this and this to stay consistent. And the program address, that's the program that we assign it to. So the owner of that account, we will assign an owner. Should we do a pseudo program? I'll do keychain again, and not a pre but a prosnet. There you go. Just so I have the key. It's not like I really need the key, but let's say our pseudo program would live at that address. We could theoretically later still deploy it there to recover those accounts with the program, but we're working on devnet, so it's not that important. Anyway, I'll put that here, it makes more sense. So my program address that I assign that account to will be the pseudo program, and that's all we do in this transaction. We have one instruction, the create account with the system program, and that should work. If we actually run this with npx tsx create that account, the simulation comes back with success. That's the transaction. I don't actually need to log this. I'm not actually that interested. And then that's my signature. So a random account. We have created it with a minimum balance for rent exemption for a 0 byte account. Oh, I love this. This is just so nice. Look at that. Wow, they changed it. I love how they're improving the Explorer. Every time I make a new video, they have a new feature. That's so cool. It used to be a download, like a copy that bytes, which I can, but now it's so much more clear what that does. So good. I love that. But anyway, that's just a system program. My account has 0 bytes. I just created it with 0 bytes because we just created it. And what create does is 3 things basically. It transfers the lamperts onto that account. It allocates bytes. In this case, it didn't allocate anything. And it assigns account to a program. Nice. That works. And that's nothing new. That's what we know. That's how we always worked with the system program createAccount. But now check this out. What if before the createAccount gets called, somebody transfers Sol to that new account, even if it's just 1 lampert? I'm gonna pay for it with my same payer. What happens then? The simulation already doesn't work because the createAccount is already in use. It says already in use because there is a lampert there. And this is not a particularly realistic example. For one, because the 1 lampert wouldn't stay there. We're just doing this in the same transaction. If I wouldn't create the account, then it would also not work because we have insufficient funds for rent. So I would need to transfer at least the rent here. But even if I did that, this is still a bit of an unrealistic example because we wouldn't transfer onto that account if we know that we will create it later. But an attacker would. To mess with us or to get a denial of service or whatever, a hacker could do that. And that's not really possible if you create a new random address. But what if that was a PDA? What if the new account we want to create is not a new key pair, but a PDA? And now I will need that up here. Of our pseudo program with seeds, I don't know, PDA. Then this new account is known because anybody who knows the seeds and the program address can derive this. So they could find out what the PDA is and then be mean and transfer to this account what is required for rent exemption, which would be 0.00089 something, whatever. And they would transfer that to this account. Yes, it's a new account. We approve that. Oh, it's not enough. What's the minimum? 000. Damn it. Okay, fine. Round that up. 000891. There you go. So now an attacker that wasn't me has just put some Sol on that account, but it's not assigned anywhere, right? It's still owned by the system program. They can't assign it because they don't have the private key and it's not a PDA of their program. It's a PDA of my program. But when my program, or even me outside, oh yeah, wait, I can't do that outside because if it's a PDA, I can't showcase this without having the actual program because I need to sign for that account. But you get the idea. The same is true if I have a fixed key pair, like if I had like a fixed something here, fixed 9, and my new account is actually this key pair. And an attacker would find out that that is my key pair, just the address. They just know my address for some reason. Then they can again transfer to this account and all of a sudden I cannot create this account anymore because it's already in use. And there's a reason why the system program handles it like that. It's because that thing is a regular wallet account, right? Maybe somebody wanted to use that as their regular wallet and now they sent some Sol there. Or maybe it was yourself. Maybe you sent some Sol there and then you accidentally call this create account instruction with that same address. For instance, if you mess up the new account and the payer or whatever, something like that should not work because that payer address is already in use. Otherwise, we would brick our own wallet. If we assign it to a program, then we can't get the Sol out anymore. So as soon as there is Sol there, the system program does not allow to create that account anymore. For a good reason. If we actually still wanted to create that account, what we would need to do to fix this, to create that fix account, we would need to do the things individually. We can't do create account, but what does create do internally? It transfers, it allocates, it assigns. Now I think transfer it actually does in the very end. And in our case, it would actually be enough to just get the assign instruction and assign that new account to the program address, our pseudo program. But that's only the case because we allocate 0 space, so we can skip that. And we know that there is already enough rent there because it must be rent exempt from the beginning. If we wanted to actually allocate space, let's say I would want 16 bytes or whatever, then the rent would be calculated as follows. Let's first do total rent is this, as before, right? How much do we need? And then current rent is get balance for the new account, and then the missing rent is just the total minus the current. So that's how many Lamperts we're still missing, because there might already be some there. So that is what we need to then manually transfer there, such that we can also allocate some space to this new account, and the space be the space. We allocate, we assign, and don't forget we need to transfer. Because if we don't transfer, let's do without the transfer, then it won't work, because then we again don't have enough rent. Oops, create account fix. We'll again error with insufficient funds for rent. So we need to manually top up with a transfer sol instruction and transfer to the new account the missing rent from wherever. Then with those 3 instructions to the system program, we would fix it. That should work. There we go. That does work. Look at that. Even though there was already rent on that account, we just topped up the missing amount and we did an allocate, assign, and transfer. So there are individual instructions to the system program, and that way it still worked. So it's still possible to do that. It's just not possible with just a create account instruction. And just to reiterate that once, the account that we allocated and assigned and transferred to, this fix 9, this one, those Lamperts are now actually lost because that account is bricked to that address. Even with the key pair, we have it, right? How much is on there? 0.005. I wanted to transfer all of what's there onto this address with the key, because I have that in my keys, the fix 9. I have that key pair. Oh, but I can't pay for it. Well, then I need to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what's on there, and then I remove the base fee. There you go. That wasn't the base fee. Hold on. Let's try that again. Wait, that was on there. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 5. 1, 2, 3. K is rent. So that 2 becomes a 7. That becomes a 9. That becomes a 9. That becomes a 0. Basic maths. There we go. But point is, that doesn't work because this account may not be used to pay transaction fees. That's exactly the problem with the bricking. I still think I coined that term because it's not owned by the system program, so you can't transfer sol out of that account. So it can't be used to pay transaction fees. So that doesn't work. And even if we would pay transaction fees with a different account, it still doesn't work because only the program that was assigned to the account, only the owning program can change the account, including the Lamperts. Just to reiterate why the system program does not allow the account to be created if it already holds sol as a security. But sometimes you want that, right? Sometimes another transaction has already paid for that account, or annoying hackers send sol there to mess with you or whatever, right? Then you have to do it like this with those 3 instructions. And 3 instructions are worse than 1. And that's why they have added a create account allowing prefund. So now we're not doing a create account instruction, but a create account allow prefund instruction. Look, it's here. It's live. It's there. It's in the SDK. Woohoo! And that should take the same things, except that Lamperts and payer is now optional. But the rest stays the same. So the new account will be this one. The program address, again, our pseudo program. The space, we can allocate the space. Lamperts and payer, we only need if we need to top up that account. So only if missing rent is larger than 0 do we need to actually provide the Lamperts and the payer. We'll have a look in a second what it means, how it would look without those. But just so we do the same as in the previous example, even if somebody transfers sol to that account beforehand, this should now work if I npx tsx create account and allow prefund. There we go. That transaction goes through. So it did the same thing as we did before with the 3 instructions. It topped up that account. Hold on, the allocation didn't really work, did it? Oh, yeah, it's just slow. There you go. Allocation worked. It just took a while to read that. It has 16 bytes. It's all 0 because it's just newly initialized. But all of that was done with 1 instruction. 1 instruction to the system program. 1 instruction, just the 150 CUs. And now you might say, well, come on, Andy, you don't save that much with that 150 CUs compared to the 450 CUs that we needed for doing it in 3 instructions. So why did they bother? Well, the execution of the individual system program instructions might not actually be resource intensive, but that's just because we're doing it on top level. Imagine that being done from a program. What do you need to do? Well, you need to CPI. And doing a CPI, we've analyzed that as well in previous videos, costs a lot of resources and therefore a bunch of CU. So doing 3 CPIs is certainly costly. And I don't want to write a program and demonstrate that to you, but just believe me that if we were to do that with CPIs, it's much better to just be able to do 1 CPI. That would save us a bunch. And also save us a bunch of logic, checking the account rents and being like, oh, is there enough there? Can we create or do we need to allocate and assign? It's just annoying. With that, this is basically an allocate and assign with an optional transfer. And the optional transfer, we wouldn't need that if we know that there's enough there. And I don't want to do it like, and I'm too lazy to once again create a new key. I'm just gonna generate a new key per signer again and do the transfer in the same transaction from my payer to the new account. If I know that the total rent was already transferred before, maybe in another transaction, maybe even in the same transaction, it doesn't really matter, then I can leave out the payer and the Lamperts here, and the create account with allow prefund will also just work. So this time this works. And again, it's the same. We just split the transfer out of the create account. But the point is that can happen anywhere now. That transfer could already have happened in a different transaction sometime earlier, and we still are able to do the createAccountAllowPrefund. Explorer doesn't know that that's the name yet, but it knows it here. And I can't do raw. What's that shit? Here I can do raw. Look, that's nice. I can look at the data. Here I can't do raw. Oh, that's just annoying. Oh, because it just gives it to me raw because it doesn't know what it is yet. Okay. So what is it? It's an instruction to the system program with the instruction discriminator 0D. The regular create account, do we still have that? That thing, the create account, if we look at that raw, that's actually instruction 0, instruction discriminator 0. That's fun. But other than that, it should actually be relatively similar to our create with allow prefund. That looks different, but the end is the same. That looks like the, what is that? Wait, because that's the new account and that's the payer. Look, that also changed. Look. Let's do the same. Because here we did it without a payer. Let's add a payer again. Maybe because only 1 Lampert was transferred there before, and now we transfer the total rent minus 1 Lampert, whatever. Let's compare that. So with the new instruction, first is the new account that we create, and then is the payer. Previously it was first the payer and then the new account. So first the from, then the new. But because the payer is optional, it comes as account 2. That makes sense. And then as for the data, that thing must be the owner, I guess, the 5dB, because that's a missing account that's not in the account list, but that we put as instruction data, the owner that we assign. So that's that. The space is that. Is that the same? That was also the same. And the Lamperts must be that then. Oh yeah, that makes perfect sense. Look, that's the Lamperts, and the difference is just here is one more than here because we sent one Lampert less. And it's 4 bytes of instruction discriminator of the system program. We had 4 bytes for that. Right, I forgot about that. It's not just 1 byte, it's 4 bytes. Cool, yeah, so instruction data stayed the same. And if we don't transfer anything, then the Lamperts is just 0. And I guess if we don't have 0 Lamperts, then we expect another account. Because otherwise, if I would say I transfer that, but I don't provide the payer, TypeScript won't complain because those two things are optional, but that will still not work because an account required by the instruction is missing. Yeah, that's what I would expect. Only if Lamperts is also 0, then it would work. But it wouldn't work because we don't have enough rent. So the instruction works, but the transaction fails because insufficient funds. Yeah, cool. Okay, analyze that as well. So instruction data stays the same. Accounts switch order, and the second one becomes optional if we don't transfer Lamperts. Nice. And that stuff works on DevNet because if we look at the feature gates, what was it? 312. The createAccountAllowPrefund was already activated, but also on mainnet, if we check mainnet feature gates, it's also already activated. It got activated a few epochs ago. Mainnet 3. So like 4 epochs ago or whatever. Very nice. This SIMD. createAccountAllowPrefund instruction added to the system program. Reduces network overhead for applications that need to fund account rent in whole or in part in advance of account creation. So yeah, here it talks about that otherwise we do 2 to 3 CPI calls, and the overhead incurred with the CPI can make up the bulk of the computation done in that transaction. Yeah, that's why they created this. Prefund, sending Lamperts to an account to pay for its rent whole or in part in a prior instruction or prior transaction. So what we're doing here is pre-funding that account. We're only partly pre-funding it, but we are pre-funding this account. And a regular create account doesn't work anymore then, but a create account allow prefund does. The instruction has a new discriminant 13. That's the 0 we saw in hex. Nice. And the other things are still true. If the funding account doesn't have enough Lamperts to transfer, obviously it doesn't work. If the new account already contains data or isn't owned by the system program, it won't work. If it doesn't have enough Lamperts to be rent exempt after the transfer, well, to be very correct, it needs to be said after the transaction, not after the transfer. Because what can happen is I transfer 1, I do this, and I transfer the remaining total rent minus 1 later. So here I could still do other stuff. Only at the end of the transaction must I have enough SOL on that account. I'm pretty sure. Yeah, look, that also works. So it's not that this instruction fails if afterwards we don't have enough rent, because that's a transaction level thing. We can't leave an account with not enough rent, but we can temporarily, like we do here. That's also why this works. We go through instructions and it's fine. So yeah, so basically this is an allocate and assign and maybe transfer, but that's the worst name, so that's not what they said. And they wanted specifically that, such that we don't need 2 transactions with allocate and assign and then a transfer. Drawbacks: interface sprawl. This is a temporary compromise and CPI improvements can land. Security considerations: developers using createAccountAllowPrefund should ensure they're not passing an unintended wallet account with Lamperts. Since the Lampert check is removed, a wallet account with Lamperts can be bricked by this instruction. Bricked! That's my word! I don't know if other people came up with the same word, but I certainly started using this when I was talking about exactly that people were deliberately bricking accounts basically to steal them. And they did that with the assign that doesn't have this Lampert check. Yep. SIMD requires a feature gate. Yeah, we're already there. It's already activated. It's already got a check. It's already live, even on mainnet. Cool. Now the last thing that's open for me to discuss is, when would you use that? Glad you asked. So it's not like this is a breaking change or anything. Everything that we have been working with so far still works the same way. They did not change how the create account works, which is good, because some people maybe depend on that their instruction fails if create account tries to create an account that already got created. That would have been a security issue if they would have just changed that, because then programs might suddenly behave differently and you don't want that. But this is an additional instruction that you can use to be more efficient. Compare it with the p-tokens batch instruction that we talked about in this video. It's not like you can't do it without that instruction, but using that instruction you can be more efficient. And it's the same way here. Using that instruction, your program can be more efficient by not needing to do several cross-program invocations. If you're initializing an account and you know that it might already contain lamperts, like that's per design that it could already contain lampert, or it's a PDA, and basically whenever you're sure that it's not a wallet account, like one that a user actually stores his sol on, you can just go ahead and use the instruction with the AllowPrefund, because that fixes you the work. And even if you do it the same way, you don't even need to check that if there's already rent on that account. I mean, you can, since if it's in the list of accounts, you can read it in your program and you can check how much rent is on there and then just allocate what's missing. But you can also go plain and put the entire rent that you expect that it needs on there. And if it already has some sol there, well, then there's just more rent there. It doesn't really matter, but it will work. It will not break if somebody pre-funded your PDA, for instance. So to avoid those attacks, that's a nice alternative. Then you don't need to go through allocate and assign. So my general rule of thumb that I came up with now is if it's a PDA, then go ahead and just use the createAccountAllowPrefund per default. Because with a PDA, the chances are higher that somebody maliciously pre-funds it, and also the chances are very low that a PDA is an actual user wallet, because it's literally a PDA from the program. So it makes sense that a program-derived address will also be assigned to the program and doesn't need to remain a system program account. If you're working with private keys, like key pairs, it's also fine to use the AllowPrefund if you know what that means and you're getting the arguments right. Just don't accidentally assign your wallet to a program that you don't have control over. Because, and I didn't show that, what I said earlier, let's show that as well with a fail. Because the createAccountAllowPrefund instruction will gladly take your payer account, so your main wallet, and brick it, or not? No, the transfer fails. I cannot transfer because it first does allocate, then it does assign, and then it does transfer. So the transfer doesn't work anymore. But if we don't transfer, and this is actually easy to get wrong, because if you just need those three accounts, it's easily to mistake the new account with the payer account, right? Somebody got to pay, well, a new account. Oh, what else do we need? This and this and this. That can actually be dangerous. Look at it. Ha! Because that comes back with success. And what's happening here is it doesn't seem like much, right? We're just paying for a transaction with our main wallet and we're doing this createAccountAllowPrefund. But we had our account as the new account in there. And in the regular create account, that was also the first account. So now we again put it at the first account. So make sure that you're getting this right, because that will succeed and that will brick that account. Why? Because now it's assigned to that pseudo program. We allocated and assigned that account to a program, which means we don't control this account anymore now. We can't do anything with this wallet anymore, even though we have the private key for it. But none of my scripts will work anymore now. They will all say invalid account for fee, because I cannot use this payer account for fee paying anymore. Because this account is not owned by the system program anymore. And it also has bytes now. So we bricked that account, and the only way to get our account back and also get access to that sol again is if that program would release it. So we, because we have that private key, could deploy that program and create an instruction that would free that account, so transfer the lamperts out again. But we would need to control that program. And if you would assign it to the token program or anything else or any other program, then you're screwed. So that's really bad, actually. So make sure that you're getting this right. And getting this right really means calling the right instruction. So make sure that you're using the correct builders of that instruction, like here with a kit or in the Rust SDK, they will also have that. If you manually build the instruction, make sure that you're using the accounts, the order correctly. Because, let's do another one. Let's call it accidental fail. And I need a new wallet, damn it. I'll pick one of the other keys that I had. They are pray. So, this is gonna be my pray now. I'll just transfer 0.1 sol to that account so it can fee pay. So that's my new wallet account now. And I'm gonna showcase something that could go wrong. Let's say you're doing a regular create account with a regular, that's the new account, that's the payer, that's the program that we assign it to, that's the space, that's the Lampert, the total rent that we require. That's a fair regular get create account instruction, and that will work, right? We tested that earlier. But what if I'm like, yeah, that's cool, but I know that on my new account there might be Lamperts on there already, so I'm not gonna do the create account, I'm gonna do the create account allow prefund. And I know that it's basically the same, just that the discriminator is different. It's not 0, it's now 13. So I'm just gonna change that and that it's gonna work. Look at that. So I'm gonna create an instruction myself, and I use basically the same things from up there. The program address from this thing and the accounts. Basically, I use the same data as my create account instruction, except I know that the first byte needs to be 13. So I'm just gonna strip that off here. And then it's basically the same, just that I now allow prefund. Right? This gonna work. Bling! Except it will work. It will work, yeah. You're right. But check this out. The pray account, that is a regular system program account, with 0.1 sol. If I execute this with an accidental fail, we have insufficient Lamperts. Insufficient 0, need that. Right, hold on. We're not done. Wait, I'm not done yet in my bad example. And I know that I can do it like that. I need that because before that there's a get transfer sol instruction as well. I'm gonna transfer that myself because I know that I can just transfer the total rent onto that account first already. Yes. Why would I do that? That's stupid. You're doing it here. But no, it doesn't matter. I know that there could be already enough rent on there. This is what I'm simulating here. That's what I'm saying. There could be, right? And the destination is the new account. Yes, please. And whoever paid for that, I'm gonna pay for that. Okay, that's fine. Look at that. And this is to simulate that there could be already enough rent on there. There could be. What am I? Am I doing a Donald Trump impression here or what? But yeah, I could be. And then check this out. If that poor guy actually calls this, look, this goes through. And what happens is that the pray account is now not owned by the system program anymore, but they pricked it. They pricked it themselves. Why? Well, in this transaction, they did the transfer, and then when they wanted to do the create account, they did the create account with a different discriminator for creating account allowing prefund, but all of a sudden the pray account is where the new account is. Earlier that was because that got switched, and the new account is now the actual payer. That's why I had to make it do the transfer just now, because otherwise that account wouldn't be able to transfer there. But the same example could happen if I would call this with 0 Lamperts, right? If they thought, they need 0 Lamperts, then we wouldn't need that transfer. But then I again need a different key. Hold on. Gotta sacrifice another one. Look, I'll sacrifice another one. This one, have some sol, and then do the accidental fail. See, now it also works without the transfer. And then it would look like this, that they're again providing the 2 accounts, but the second one is getting ignored because Lamperts is 0. So nothing happens with this account, but we accidentally brick our main wallet. That's what's happening here. Nothing happens to this account, but this one gets bricked and it ends up being assigned to a program. So same thing here when we did the transfer before. So the pray account in that example, fell prey to our own stupidity in creating this instruction. Because yes, it's a create account instruction, and yes, the discriminator changes, but also the account order changes. So this is really important, and that's why I want to finish with this. If you're doing this, if you're manually building your instruction, make sure that you're getting the account ordered correctly. It's not just changing the discriminator, it's also changing the account order. Make sure the first account you're passing in there is the new account and not the payer account, because otherwise you're bricking the payer. And it will not even warn you, and it will not fail, because that's exactly the point of it. It will not fail if there's already lamperts there. So use this instruction carefully. But yeah, if you're creating a new account and you're using the correct instructions, and you're using the correct instruction and the correct instruction builder, then it should be safe. Maybe I'm blowing this up too big, because 99% of people are gonna get that right, probably 99.9. But there's the 0.1% that get it wrong and then complain to me that I said, yeah, I should update, but then they brick their wallets and then they come to me, yeah, can you fix it? I can't access my Sol. And I'm like, well, I'm sorry, I can't do anything about that. Once it's bricked, it's bricked. Can't get your Sol back unless you own the program. So yeah, I'm leaving you with this. Be careful with it, but it's cool that we have a new instruction in the system program now. I love it when stuff changes. Is it really worth it in terms of compute efficiency? Try it out. This is your homework. Do that thing that we did here, the allocate, assign, and transfer as CPIs, and then compare it how much more expensive it is compared to just doing this one CPI to the create account and allow prefund. That's your homework for today, and I will leave you here. Yeah. It's cool. I like this instruction. I just like it that they're improving even the core aspects of Solana. If even the system pro, which is like the most core program, is getting updates, I just think that's cool. And as a Solana dev, I want to know what changes here, and I want to be able to use it correctly and know when I'm using what. Because obviously you don't want to break things. And I think I did a good job explaining that. If you agree that I did a good job explaining that, go give me a like, subscribe if you have not done that already, and watch some other videos of mine if you feel like doing so. And then I will see you in the next one. Till then, make sure you're using the right instructions and enjoy your Solana development journey. It's fun. It's fun. I just enjoy it. I just really enjoy this. As you can tell by my facial expressions. I really enjoy this. Okay, bye!